Today's topic is Sumpners Test. Sumpners Test is also called as back-to-back test. In the previous sessions, we have learnt about OCSC test. So this is also known as Sumpners Test. Sumpners. In the previous sessions, we have learnt about OCSC methods. So the Sumpner test is also another method of determining efficiency, percentage regulation and heating under load conditions. So generally the OCSC test which we performed, which will gives us the equivalent circuit parameters, but the one which we will not be able to obtain from the OCSC test is heating information. Please remember this. So the heating information will not be able to obtain under the OCSC test conditions. Hence, this Sumpner test will give us heating information also. So what we did in OCSC test, there was no load applied on the transformer, while in the SC test, only the fractional load gets applied through the help of short circuiting. So in all the OC and SC tests, so the loading condition, exact loading conditions are absent, and so hence we can consider that exact loading conditions are at the whatever the results we have turned are inaccurate. So in Sumpners, actual loading conditions are obtained or simulated. Hence, the results what we get from the Sumpner test are more accurate when we compare with the OCSC test. Now, let us understand what is this Sumpner test, why this Sumpner test is required. So, as I said, the maximum temperature rise, in order to obtain the maximum temperature rise, so we need to conduct the full load test on a transformer. Also, a suitable load to be connected on a full load power of a large transformer. If at all, let us imagine a huge transformer. There it is very difficult to connect the complete full load power only for the testing purpose. So also it will be very expensive as large amount of energy has to be wasted just to load for the purpose of test. So what they do is large transformers can be tested for determining the maximum temperature rise by back-to-back test. This test, the other name of this test is also is regenerative test. Regenerative test. It is also called as regenerative test, back-to-back test or Sumpners test. So what it requires? This transformer requires two identical transformers, transformer 1, transformer 2, just like in the case of OCSC test. OCSC test we performed separately. In the OC test, one transformer we used, in SC test, one transformer we used, and we performed separately. Here, two identical transformers. You can observe here, this is transformer 1, this is your transformer 2. And the primary windings of both the transformers are connected in series. When you observe here they are connected in series with their polarities in phase opposition. So generally which can be checked using the voltmeter technology. So the polarities will be read there. Now the polarities can be known here by the voltmeter there across which we have connected here. Now the range of this voltmeter whatever we select should be double. If it is 230 volts we are applying, so range of this voltmeter should be 600 volts. Now the secondaries, in order to check that secondaries are connected in series opposition, so generally we check the voltmeter, across the voltmeter should read the 0 voltage. If not, we will replace the secondary terminals, secondary set terminals will be interchanged. So this is what generally we do if it doesn't read. Now how the test results are obtained here? It is almost the Sumpner test is similar to OCSC test because here both the transformers are connected back to back of one another. Here in the series, primary are connected in series and the voltage is connected across. When you observe the secondaries, they are connected across the load. Now how it is operated? It is similar to your OCSC test. In OC test, Similarly, in the initial OC test, we obtain the voltage parameters, or we will not apply any load current will be very less, and in short circuit test, we will obtain the maximum load current value. Similarly, here also, initially there will be no current in the secondary windings because no load applied. Now, first and foremost thing what you have to remember is voltage to be supplied. Rated voltage will be supplied the primary circuit. After closing the primary circuit, the total voltage across the secondaries in series will be 0. So we will note that whether the voltmeter 2 or voltage across is 0. If it is 0, we will assume that it is in proper series opposition polarity. Now at this condition, the secondaries are open. Secondary circuit is open. That means no load current will be passed. So what are the readings we are obtained? We are going to obtain the wattmeter W1 reading here, which gives the iron loss. For a transformer, we can obtain as W1 by 2 as T1 and T2 are identical. That is transformer 2 are identical in nature. So at this condition, a small voltage is injected in the secondary circuit by a regulating transformer, that is auto transformer, which is excited by the main supply. Now, second, once you obtain this reading, the magnitude of the injected voltage is adjusted till the load current, that is your I2, will read the full load secondary current. Now, once after closing the circuit, you have to obtain this. Now, the secondary current which produces the full load current to flow through the primary windings. So, this current will follow a circulating path through the main bus bars. So, that can be seen in the circuit. So, at this condition, we will be able to obtain the wattmeter reading W2 and the current I2. So, the wattmeter W2 will give you full load. This will give you full load copper loss of the transformers. Both the transformers readings can be obtained. So, in this method, what is the difference when we compare it with OCC test is we have loaded the transformers to full load, but the power which is taken from the supply is that necessary to supply the losses of both the transformer. So, we will be able to obtain the temperature rise of the transformer that can be determined here by operating these transformers back to back, that is they are connected back to back for a long duration, say for 24 hours like 1 day or 2 days or 48 hours, and each hour you will be able to obtain the temperature readings. Means when both the transformers are connected together, what will be the temperature effects, and we can be able to measure the temperature of the oil at periodic intervals of the time. So, you can measure every hour or every 2 hours once. So, in this method, apart from obtaining the regulation efficiency, we will also be able to obtain the temperature parameters. Thank you.